Hi. I usually ask one question during the interviews, and most of the time I don't get the correct answers. And not even the freshers, even experienced developers, most of the time don't give me the correct answers, correct replies. So let's check out the question. So question is in front of you. What happened that let's say suppose we have an array and this array is too big. Let's assume this array is having more than or around 1 million entries. And the best part is that this array is not, ordered in a particular sorting order, either ascending or descending, even though values are randomly available. Fine. So let's say suppose I want to search the element, I want to search the target, and I want to search it fast. I want to search it in a more efficient way. Okay. So how we can do that? So what my recommendation is that you also pause the video for 10 seconds and give me the answers in the reply. So what happened exactly? Usually I get the answer something like as that we should sort the array and then after we can find the element so easily. Okay. But that's not a correct approach, right? Why? Because sorting how we will get the element in the correct way, first of all, and sorting itself is a costly affair. Sorting itself makes the entire system slow. And let's say suppose if we have to only execute this algorithm 5, 6 times out of a 1 million array, then doing sorting is not the correct operation, right? It is not the correct answer. So what would be the another approach? Because sorting is not making any sense in this scenario. So I usually give my other another opinion, and most of the people is saying that okay, this answer is correct, this answer is correct. Yes, yes, this will work fine. But to be very honest, okay, let's discuss the answer first of all. So what happened? Let's say suppose I can divide the list into two parts. So now during the for loop iteration, what I can do, or any loop iteration, what I can do, I can iterate it from this side as well as I can iterate from this side, right? As well as I can iterate from this side and as well as I can iterate from this side. So it means that I can have a 4 pointers. Let's say, for example, I can have a start, right? And this can I consider mid left. This I can consider as mid right. And this I can consider as end. Okay. So let's assume that we have a 4 pointers. So what happened? Let's say suppose if I want to search 4, I can get the 4 very easily on the fourth iteration. Okay. But let's say suppose on the other side, if I want to search 33, I can get it on a very first or a second iteration or first iteration, right? 0 or 1 iteration, I'll get it. On the same time, let's say suppose if I want to go for 13, so I can get it on a second iteration. Okay. Yes or no? And 108, I can also get it on a very first iteration, Okay. So usually the people are saying that, okay, this is a very good solution. This solution works well, but this solution is not the optimized one as well. This solution is not the good solution. So you know why this is not good. So let's go together and hopefully I can demonstrate this example to all of you in the best possible way. So this is the STS and let's create a Java project. Let's say uh, so right here what you can see, let me execute this code. So when I'm going to execute this code, you can observe that we will have a 20 elements and all the 20 elements are randomly available. Means position is not ordered, right? And all values are present, right? So means 0 to 1 to 20 elements are present. None of the element is missing, but they are randomly available within this entire, array. So let's convert it to 1 million. So ones, tens, 100,000, 10,000 lakh, 10 lakh. Okay, or let's make it 10 million. So now we have how many records? 10 million records. Okay. So let's write the code where we are implementing 4 pointer solution. Okay. So sorry. So public void 4 pointer solution. So this one is working. Let me add it again. Let's execute it again. So let's say 19,68,950. Okay. So when I'm going to enter it, that element is available at two last, but in order to execute this number, I I have to iterate only 24 lakh times. Okay, which is fair enough. But let me add time counter there as well. Let's execute it again. So in order to execute that number, the process takes 14 milliseconds. Okay. Now, in order to understand the whole process, first of all, let's execute the whole code through the basic approach. Okay. So in order to do the whole task through the basic approach, what I'm doing, I'm just using the simple search, right? Public static int simple search and int arr and int tar. Okay, so let's do the same code again. So what I'm doing right as of now, I able to implement it. So let's recap the things what I have done. So I have already shown you that we have a very huge array, and in order to search the element, what I'm having, I have a two approach. First is this, and second one is this approach. Okay, so I have these two approach in order to search the element. Here I am having a four pointer solution where I'm searching from the four ends in the same iteration, whereas this is a simple search, the conventional search, whatever what we have with simple search. If element is double equals to the target which we am looking for, then I'm returning the position. That's it, nothing else. Okay, so let's execute it. So now I'm going to search it. So this is the same number, and now look at the solution. My typical logic takes 12 milliseconds, but the simple search takes only 5 seconds, 5 milliseconds. Okay. However, the count value is different. It actually going to iterate more, but still that is fast. Okay. Test the application with more inputs. Let's say 85 lakh or 8.5 million. Okay. For other audience. So what happened right here? This element is available at somewhere very far, but what happened that this takes the fancy logic, the algorithm takes 15 milliseconds, but the conventional simple algorithm takes only 8 seconds, right? So why this code is taking much more time and the simple logic takes less time? So the solution lies right here. When we use the simple array, when we use the sequential array, CPU loads the nearby elements into the cache, and this makes the access extremely fast. Whereas in the previous approach, when we are using the four pointer solution, we are basically jumping across the pointers start and mid left, right, and it breaks the cache works. It CPU cannot efficiently use the memory locations. CPU is wasting its resources in order to switching from start to mid to end, mid right, right, something like this way. As well as there are the four process also engaged inside, right? We are checking the four conditions inside each iteration. So more comparison means more CPU work. CPU has to do a lot of work there. So in a nutshell, I just want to tell you that optimization is not all about doing more work per iteration. It's basically, it's basically the doing the code or in the CPU friendly way. Okay, if someone is asking in the interview such kind of a question, so the simple answer is the sequential access is always faster because it can use the cache efficiently, whereas a complex logic sometimes reduce the performance. I hope you enjoyed this video. If you have watched this video till at this end, so
I expect you to subscribe this channel and share this video. Thank you guys for watching my video.